Let's look at example 12. A soft drink maker claims that a majority of adults prefer its leading beverage over that of its main competitors. To test this claim, 500 randomly selected people were given the two beverages in random order to taste. Among them, 270 preferred the soft drink maker's brand, 211 preferred the competitor's brand, and 19 could not make up their minds. Determine whether there is sufficient evidence at the 5% level of significance to support the soft drink maker's claim against the default that the population is evenly split in its preference. All right, now let's notice here that we are talking about a percentage. Essentially, if it's evenly split, we're going to have 50-50, 50% that like the soft drink maker's brand, and 50% that prefer something else. So let's start our hypothesis test. So we're going to start out the same way. We're going to start with our null hypothesis, but this time we're going to use P because we're talking about a proportion, and we're going to say P is 50%. And the claim that these people are making is that their brand is preferred more, which means that more than 50%, more than the majority, or more than half the people, the majority of people, prefer this brand. All right, and we had that alpha was 0.05. All right, now this is a right-tailed test, so we're going to look up our critical values. And remember, with a right-tailed test, we have to subtract this from 1. So we're going to look up 0.95. There were 500 people in the sample, so it is large. So we're going to use our norm.s.dist. I'm sorry, not dist, but inv. And we're going to look up 0.95. And we get 1.645. All right. So our critical value here is going to be that C is 1.645. Now, since it's right-tailed, anything to the right of 1.645 will be in the rejection region. Now, we have a different test statistic for our proportions, so let's look at what that is. All right, so if we go back, I just want to pull up the test statistic for us. There it is. We have P hat minus the null hypothesis P over the square root of that null hypothesis P times the null hypothesis Q over N. All right, so first thing we need to do is find P hat. So let's go back to our example for a minute. Oops, I'm on that page actually. And we had that 270 preferred the soft drink maker's brand out of 500 randomly selected people. So for P hat, we're always going to use the amount that preferred whatever we're talking about over the total amount that we had. So it's going to be 270. Before we do our test statistic, P hat is 270 divided by 500. And if we put that into our calculator, that gives us 0.54. All right, now let's do our test statistic. We want on top P hat minus our proposed proportion in the null, 0.5, divided by the square root of this proposed proportion, and then 1 minus that, divided by the number in our sample space, 500. All right, so let's do that calculation. On top, we're going to have 0.04. On the bottom, we're going to have 0.022361. And then if I divide that out, I'm going to have 1.789. All right, so let's notice 1.789 is to the right of our 1.645, and of course our test is right-tailed, so this is in the rejection region. Since it's in the rejection region, we reject the null hypothesis. All right, so let's make our conclusion. There is significant evidence alpha equal 0.05 to reject the null hypothesis. It does appear that people prefer this manufacturer's brand of, I believe this was a drink. Just looking back. Yeah. Okay. All right. Now, let's just, while we're here, think about this using the p-value approach. Remember, if we had used the p-value approach, we would not have found the critical values here. Instead, we would have taken this test statistic of 1.789 and looked up the p-value. And of course, if we do that, equal norm.s.dist 1.789 true, we would have gotten this. Now remember, since it's a right-tailed test, we have to subtract this from 1. So 0.9632 subtracted from 1. And we get 0.0368. Now, remember, when doing a p-value test, we have to compare that to alpha, and it is smaller than alpha, which means we still reject the null hypothesis. All right, and then here, instead of saying alpha equal 0.05, we would say there is significant evidence, and we would change this to the p-value, which is a little stronger. Oops. 0.0368, and of course the result is exactly the same.